All right, so for the last couple problems in this section, or the last few problems in this section, we're going to do what's called sinusoidal curve fitting. We're going to do it by hand, and then we're going to use our calculator to do it as well. So the first thing that we're going to do is I'm going to show you this data on the screen. And we're going to talk about it for a second. So hurricanes are categorized with winds of 111 to 130 miles per hour, corresponding to a category 3. 131 to 155 is category 4, and in excess of 155 is a category 5. The following data represent the number of major hurricanes, H, in a certain, oh look, there's a spelling error, in a certain region, which would be, and so it's going to designate only the hurricanes that reach 3, 4, or 5. So it's not going to count a category 1 or 2. On each decade X from 1921 to 2010. Answer parts A through D. So if we look, our X column represents the 20s, all the way up to 1930. And then it goes 1931 to 1940, but they've told us to use 1 for decade 1, 2 for decade 2, 3 for decade 3, etc. So what I'm going to do is I am going to show you on my calculator how to get this thing entered. So the first thing I want to do is I am going to clear my memory just so that I have a clean slate everywhere I go. All right, so what I want you to do first is, let's zoom in on this and turn the light off. That might make it a little bit easier. And I'm going to focus. Here, let's get rid of this. Let's just put white paper underneath here. Okay, so I am going to focus on the calculator screen. That is so pretty. It doesn't know what it's doing. Okay, there we go. So what I want you to do is we need to make a list of X values and a list of Y values. So we're not going to use the Y equals for this. I'm going to use stat. So I'm going to press the stat key. And the first thing I notice is that I'm allowed to edit. Okay, so I'm going to hit enter, and it's going to tell me, okay, give me some values for list 1, give me some values for list 2. So I know I had 9 values. So I'm going to do 1, 2, 3, 4, 5, 6, 7, that's not a 7, 7, 8, 9. Okay, and I notice I can just move from one to the other just by hitting enter. So now I'm going to go to column 2, and I need to bring this up so I can't quite see what you're doing. Let's go this way. Okay, so in column 2, let me just go ahead and enter those. It's going to be 18, 20, 37. So I've got 18, 20, 37. And then I've got 18, 22, 36. 18, 22, 36. And for my last column, 19, 20, 35. 19, 20, and 35. So I've got my big picture. I've got my 9 data points. So these are just coordinates on a plane. Okay, so 1, 18, 2, 20, 3, 37. All right, so what I want to do is do this sinusoidal curve fitting by hand. And I want to show you where we're headed first. And then I'm going to show you how to do it by hand. Okay, so first thing you need to do is hit second and do the stat plot. Okay, because that's going to show you what we're doing. You can just do Y equals and go up to the plot with your arrow and hit enter. Okay, well, what happened? You don't know. So hit second Y equals. It takes you to the stat plot. So what it's going to do is it's going to plot points. It's not going to connect dots. It's not going to do anything like that. And where is it getting its points from? From list 1 and from list 2. So this is going to be your X coordinates and this is going to be your Y coordinates. Now, if we hit graph, I don't see anything. Why don't I see anything? Well, I don't see anything because my window is at, come on, focus. I believe in you. Okay, so my window goes from -10 to +10 and -10 to +10. So I need to incorporate all the data that I use. So I'm going to go to window and I'm going to change my window. So my X-min, I'm just going to make 0. Okay, because I started with decade 1, decade 2, and we're going to go ahead, even though we've got 9 decades, I'm going to go ahead and go up to 15. Okay, and so I've got some perspective here. So I made my X values from 0 to 15 instead of from 0 to 9, because I want to be able to see every data point. I don't care about the X scale. That just means my little tick marks are going to be 0, 1, 2, 3, 4, 5. Okay. So the next thing is going to be my Y min. Well, I've got a category 0. Actually, we're doing quantity, sorry, not category 0. So I'm doing a quantity of 0 all the way up to, I'm going to say 45 because I know I didn't have any 40s. So I'm going to say a Y max of 45. So the height of my window is going to be 45. And then it's going to tell me what my Y scale is. And then I'm going to go ahead and hit graph again. And oh, look, there is my data. So if I look at this a little bit clearer, it kind of sort of looks like it's coming up like this, and then it's dropping down and coming up and dropping down, coming up and dropping down, and my pen wasn't moving the same way I was talking. But that's what it looks like it's doing, and you can see you've actually got 9 data points. So we're going to try and make a sine curve that matches that data. We are going to make a sine curve that matches that data. So I'm going to use the fact that I've got my little list right here. So I'm going to go back over to stat and I'm going to edit my lists. And the first thing I want to do is figure out what my amplitude is. And so if you'll remember, your amplitude comes from the middle of the wave and it will go equal parts high and equal parts low. So I need to find my lowest data point, which is 18. And I need to find my highest data point, which is 37. Okay, so I've got 37 minus 18. So that's the height of my wave, is 37 minus 18. So my amplitude, hang on, I want a better pen. My amplitude, right, is going to be the largest data point minus the smallest data point. But that tells me the height from the trough to the peak. So I only want half of that thing. That's what I want. So what I'm filling in is my function is going to be, and I'm going to have this sine of something x, and I'm going to keep going like this. So I'm going to fill in these with other blanks. So my largest data point, I already forgot what it was, 37, and my lowest data point was 18. So what I have is 37 minus 18 is going to give me 19. 37 minus 18 is going to give me 19. Okay, and that's going to be over 2. So my amplitude is going to be 19 over 2. That is your amplitude. Well, now I need to know the period of the function. Okay, so the period of the function, the way I'm going to look at this is I am going to determine what the period of the function is. And remember, I'm going to have to put that into my little 2 pi over thing. Okay. So the way I'm going to determine the period of my function is I'm going to look at this list again, and I'm going to find 2 peaks, meaning I'm going to find 2 high points. Okay. I could also find 2 low points, but in order to be specific, we're going to find 2 high points. Actually, they did that on purpose. That's kind of nifty. Okay. So how do I get from high point, which is 37? So that's a peak. So just like, remember plotting our cosine curve, we went from peak to peak. So I'm going to have a peak at 37, and that's at decade 3. Where is my next peak? So my next peak is at 36, which is at decade 6. So it's taking me 6 minus 3. It's taking me 3 decades to go from peak to peak. And this is not an exact science. Because if you'll notice, I go from 37, 3 decades later, I go to 36. 3 decades later, I go to 35. So my period appears to be 3. Okay, but if you look at the troughs, I'm going to go from 1 to 4. And, well, okay, well, that just kind of blew me out of the water. All right, so I still have 3 in that direction as well. There's another data set out there that it doesn't do that. So just know it's not an exact science. But anyway, it's going to take me 3 decades to get from high point to high point. So I know in order to figure out the period of my function, I'm going to take 2 pi, okay, and I'm going to, I need that to equal 3. I need that to equal 3. So what coefficient do I need in my equation in order to make this thing happen? So I'm going to cross multiply, and I'm going to get 2 pi times 1 equals 3b, and then divide both sides by 3, and I'm going to find out that my b value is 2 pi over 3. Okay, so my b right now is 2 pi over 3. And now I got to figure out my phase shift. Okay, and so I'm going to figure out my phase shift by looking at how many units. Okay, so I need you to realize that a phase is the same thing as a cycle. So our phase takes place for a sine curve over 4 distinct units. Okay, so let me show you our unit circle, which I've lost somewhere. Look, I found it. Okay, so our sine curve spreads out over 4 distinct parts. It spreads out over quadrant 1, and then it's going to peak out at 1. Then it's going to do quadrant 2, and it's going to hit the axis. Then it's going to do quadrant 3, and it's going to hit -1, and then it's going to do quadrant 4 and return back to 0. So whatever we do here, whatever we find, we're going to divide by 4. We are going to divide by 4. All right, so what do I do at this point? Let's go back to what we have. I'm trying to find out what my phase shift was. So remember that the phase shift is the ratio of -c over b. That's my phase shift. So what I need to know is, first of all, when do these things start repeating? Okay, when do they start repeating? And I will figure that out by looking at my data points. So when I look at my data points, I'm going to be able to track what I need to do to start repeating. Okay, so let me formalize that just a little bit. And when I do, hang on, my computer just froze. What is happening? Why did my computer freeze? I don't know if I'm still recording. Let's do that. Okay. Okay, I thought my computer was frozen. I don't know if it was or not. So here's what we've got. I told you that we're going to divide by whatever we get by, we're going to divide it by 4. So what was our period? Our period was 3. Okay, so we need to divide that period into increments of 4. So let me give you a different representation, a different visual of that. This is quadrant 1 unfurled. Okay, from here to here is quadrant 2 unfurled. From here to here is quadrant 3 unfurled. And from here to here is quadrant 4 unfurled. So that's why we're dividing by 4. We will always divide by 4. Okay, so I need to take the period that I have, that is 3, and divide it into equal parts of 4. So what I have is I've got 1, 2, 3, but I'm going to divide that into fourths, which this is awfully convenient because each portion will be 3/4. Okay, so I've got 3/4 to here. Okay, plus a 3/4 is going to be 2/3. Okay, so that's 2/3. And then plus a 3/4 is going to give me whatever that is, 2/3 plus 3/4. Hang on. 2/3 plus 3/4 is, math, fraction, fraction. I get 17/12. And then if I add it again, I will end up with 3. Okay, so 3/4 plus 3/4 is going to be 6/4. That's why I wrote that wrong. 6/4, which is 3/2. Sorry. So that whole thing was wrong. Let me back that. All right, so we will always divide by 4. Sorry, I keep pausing. All right, so what I have is my period of 3. So whatever your period is, I now need to divide in equal units of 4. So my period of 3, I need to divide into equal units of 4. So if this is 0, okay, I've got 1, and then I've got 2, and then I've got 3. So this is 0, 1, 2, 3. Well, luckily, this little ratio right here is perfect. If it was improper, I would just change it into a mixed number. So every 3/4 of a unit, I am going to have, if I do that, I will have 4 equal units. They're just going to be lengths of 3/4. So this is going to be 3/4. Well, 3/4 plus 3/4 is 1.5. So that's going to be 3/2. And then 3/2 plus 3/4 is going to be 6/4 plus 3/4 is 9/4, which is 2 1/4. So that's going to be right here, which I believe I just said was 9/4. And then the remaining 3/4 will be here. So now I've got this thing divvied up into 4 equal units. Okay, so these are my increments. Now, why did I do that? Because now I know that 3/4 of the way through, I should have a peak. Okay, 3/2 of the way through, I should have a valley. And at 9/4 of the way through, I should have a peak. And at a full period, I should hit 0. Okay, so I should 0, peak, and then valley, and then keep going. All right, so what I'm going to do at this point is I'm going to find my tallest data point. So go back over to here. Find your tallest data point. So my tallest data point is, focus. My tallest data point is at unit 3. So at decade 3. So what I want to do is take 3 minus where my maximum is. Because remember, it should go up like this. It should go up to here, and there should be a max right here. So I'm adjusting this. My max is at 3. My max should be at 3/4. So I'm going to take where it is minus where it should be. So I get 12/4. Do I get 12/4? I need a 12 here. No, I know. I need a 4 here. Can you tell I'm exhausted? So I get, yes, 12/4 minus 3/4 is 9/4. So I have a positive phase shift of 9/4 of a unit, which means we have almost filled this thing in. Okay, I have almost filled this thing in. So what I have right here, now here's the issue. You're substituting your x minus 9/4. Remember, it's going to be minus 9/4 because you changed the sign. So what I have at this point, come down here, is I have my 2 pi over 3, which is my period. And then I have x minus 9/4. And now I just need to distribute. So 2/3, or 2 pi over 3 times x is 2 pi over 3x minus, and then my 3 and my 9 are we going to, I don't trust it. I'm too tired to do this. So I've got 2 pi times 9 is 18 pi's over 3 times 4 is 12. I can divide those by 6. It's not pi. I can divide both of those by 6. So my 18/12 is actually going to reduce to 3/2. So you are 3/2. So this part is now minus 3/2. The only thing I got left to do is I've got to shift this thing up or down. So my vertical shift is going to be an average. So my vertical shift, I'm going to add the largest and the smallest over 2. So my largest, I don't remember, my largest was 37, my smallest was 18. So I get 37 plus 18, and I divide that by 2, which gives me 55/2. So this is now plus 55/2. So all of that has taken us, I'm trying to track, that's taken us 20 minutes so far to get to this point. Okay, so let us enjoy the fact that we have a graphing calculator. Let's go back to a white thing right here. What I'm going to do is because you're going to have to enter what I just showed you, but you are also going to have to enter what your calculator tells you. So what I'm going to do is I'm going to tell it to do what's called a sinusoidal regression. So it's going to take my data points and it's going to force a sine curve to fit. So kind of like what we did by hand, but it's going to be more exact. So I'm going to hit stat. So remember, I've already got in my edit, I've already got list 1 and list 2. I'm going to go over to calculate, and I'm going to go up until I see option C, which is a sinusoidal regression. So I'm going to hit that. By default, it says how many iterations do you want? Well, 3 is great. Okay, I don't care. What is your X list? It's found in L1. What is your Y list? It's in L2. So if you'll remember, I cleared my memory. This is your default. This is what this will be. I don't care about what the period is, and I'm just going to tell it, please go calculate. When I hit enter, it's going to think for a second. And then look what it's going to tell you. Your amplitude is 11.057. Okay, your amplitude is 11.057. That's the actual amplitude, okay? Your B value or your omega is 2.088. Your C value is 1.719. And your D value is 25.015. So we estimated this did exact, okay? We estimated, and this did a more exact, I should say. It's not perfect, but it's a more exact. So now you can fill in your A, B, C, and D when you get to that point in your calculations. So you'll just have to look at the graph from there, but we've walked through how to do one of these. You got 3 more to go. So let me know if you have questions, and you're now ready for your test.